Hello friends, welcome back. Today we would continue with our discussion on trigonometry and we would look at solving numerical problems related to T ratios or trigonometric ratios. We start with this simple problem. Now this is the question. If sin A is equal to 8 by 17, find cos A and tan A. So what is given is sin A and we need to find cos A and tan A. So for this question there is no figure given. So if there isn't a figure, we will first have to draw a figure. I have drawn a right angle for you. I have called it ABC. Now you need to be a little careful when naming the vertices and the sides, because if you look at the question, it says sin A. So sin A could be either here, where I have taken A as here, or you could have A here as well. Instead of C, you could have A, B and C like this. It's up to you, because they're not. One thing for sure is, A cannot be here. There can't be any trigonometric ratio at the right angle. So it has to be at one of the acute angles, either at this side or at this side. I have taken it here. If I have taken it here, then this becomes my opposite, BC becomes my opposite, and AB becomes my adjacent. AC, of course, is the hypotenuse. Now, what is given in the question? In the question, it's given sin A is equal to 8 by 17. Now, what is sin A? Sin A is opposite by hypotenuse. We've learned that earlier. And we also know the sides from the figure, that opposite is BC and hypotenuse is AC. Now we are also given from the question what is sin A. Sin A is 8 by 17, right? So we given sin A as 8 by 17. Now you might think that BC is equal to 8 and AC is equal to 17, but it doesn't work that way. You need to be very careful when you formulate the next step. In the next step, I'll explain this to you. We will not say BC is equal to 8. We will say let BC equals 8K and AC equals 17K. And what is K? Where K is a constant. Okay. So let's understand this. What is this K and why have we used this K? Now, if I have, I'll just give you an example. So if I have a ratio 2:3, which we write as 2 by 3. This is a ratio. This is not the actual fraction. The actual fraction would have been either maybe 4 by 6 or 10 by 15, which when reduced gives me 2 by 3. So 2 by 3 is a ratio. It is not the actual value. Same way here, 8 by 17 is a ratio. It is not the actual side. So you can't say BC is 8 and AC is 17. That is the reason we say BC is 8K, AC is 17K. And K is a constant. Now, so here, if we go and substitute opposite, BC is 8K. So I'm going to write BC here as 8K. just write it here. So BC is 8K and we know that AC is 17K. So here I'm going to write 17K. So we have the opposite and the hypotenuse because that is what sine is, but we don't know adjacent. Unless we get the three sides, we will not be able to find out cos and tan. So here, how do we find out the adjacent side? By using Pythagoras theorem. You know what Pythagoras theorem is? Pythagoras theorem says that the hypotenuse squared is equal to the sum of the squares of the other two sides. The other two sides are opposite and adjacent. Now let's substitute the values here. We know what is opposite. What is opposite? Opposite is 8K, right? Opposite is 8K. So I'm going to write here, or before that, hypotenuse. What is hypotenuse? Hypotenuse is 17K. So I'm going to write 17K the whole square. Remember to put the bracket and then the square, because you're not only squaring K, but you're squaring both 17 and K. It's a single term. So 17 squared is equal to opposite square. Opposite square is 8K. So I got to square 8K. And adjacent square, I don't know what is adjacent, so I will leave adjacent as AB squared because I don't know. I need to find out. That is the intention behind this. Now, what is 17K the whole square? 17K the whole square is 289K squared. K also needs to get squared. Is equal to 8K the whole squared. 8 8s are 64K squared plus your AB squared. Now what I'm doing is I'm bringing the 64K squared to the left hand side. 289K squared minus 64K squared is equal to AB squared. Now what is 289K squared minus 64? That will give me 225K squared is equal to AB squared. Okay, which means, I just write it here. So AB squared, I'm just writing AB squared on the left side and 225K squared on the right side. So AB squared is equal to 225K squared. So what is AB? AB is the square root of 225K squared. Square root of 225 is 15. Square root of K squared is K. So what is AB? AB is 15K. That's what we want. So I can go and substitute 15K here for adjacent. So adjacent is now 15K. I've got the three sides. 15K is adjacent, 15K is adjacent, 8K is opposite, and 17K is hypotenuse. Now we can solve any ratio that they ask for. Sine you don't have to give because sine is already given. So I go to cos A. What is cos A? Cos A is adjacent by hypotenuse. And we know adjacent is 15K. We've derived that now. 15K using Pythagoras theorem. We know that adjacent is 15K. Hypotenuse is 17K, right? It's 15K and hypotenuse is 17K. Now what happens here? K and K gets cancelled. So 15 by 17 is your cos A, right? Similarly, tan A is opposite divided by adjacent. Opposite I know is 8K. So I write 8K. Adjacent is 15K. That's the one that we derived from Pythagoras theorem. K and K gets cancelled, 8 by 15, and that's your answer. So sin A already given. We found out what is cos A and what is tan A. Now, if they ask you cosec A, sec A and cot A, you don't have to do all this. You just have to say cosec A is inverse of sin A, and then put the, what is sin A? Sin A is 8 by 17, so this will be 17 by 8. The inverse of this will be cot, will be secant, and inverse of this will be cot. So as simple as that. Okay. So that concludes this question, and we will do a few more questions related to trigonometric ratios in the upcoming sessions. Thank you.